Hey guys, welcome back to Pre-Calc and Trig. Today we're doing 1.3, 12 basic functions. So we're looking at the 12 basic function graphs and we're talking about transformations off of these graphs. And so we're going to figure out what graphs can tell us, look at the 12 basic graphs, and then analyzing them. Okay, I know I said it a zillion times, but Desmos.com/calculator. You need it, okay? So it's gonna help and save your life and make your life so much easier, especially for this chapter. So if we have f of x is equal to x, that's just a line, okay? And so all of these that we're about to go over, all of these 12, these are the like OGs, like your parent function. Everything is a transformation off of these, like all of linear. So if like we have y equals x, if we had y equals 2x minus 3, okay, that would be down 3 with a stretch of 2. And that's a transformation from our parent function, our OG, f of x is equal to x. So everything that's different or anything that moves with your graph or with your line is a transformation from that. And so these are all of the parent OG, just as original basic graphs that you can get. So this is linear, the identity function, and we have the squaring function, which is a quadratic, f of x equals x squared. Looks like it's a parabola, little 2 makes a u. The cubic function, cubed, okay, looks like that. Then we have reciprocal function, so f of x equals 1 over x. Anything that's off of that, so it looks like this. We have the square root, my mouse is in the way, but the f of x equals the square root of x. Okay, this is the square root function. Exponential function looks like this, so that's f of x equals e to the x power. Okay. Then we have natural log functions look like this. You have 0 as an asymptote, and then it's all your positives. Sine of x, we'll kind of go into more with pre-calc and trig, or the trig part of it. So for sine of x, you start at the origin, you go up to 1, and you go back down, and then the cycle starts over. So like that would be 1 period. But with sine, you start at your origin, go up, down, and then there's that cycle. With cosine, you start at 1, and you go down, and then that is 1 cycle. And so they're they have the same shape, it's just sine starts at the origin, cosine starts at 1. Okay, and those are your originals. Then we have the absolute value function is a v. Then we have the greatest integer function, looks like that. And then we have the logistical, or the logistic function, and so like the 1 over 1 plus e to the negative x power. And it looks like that lovely thing with a asymptote at 0 and at 1, okay? And so we're gonna be basically just answering questions over transformations. Use Desmos. It's gonna make your life so much easier if you need to. So let's look at this one. And so we're analyzing a function graphically. We're gonna answer all of these questions, A through D, plus I've added domain and range. And then we're going to answer it based on this graph. And so if it says to graph the function y equals x minus 2 squared, or if it asks question over that graph and you're not given the graph, go to Desmos, graph it so you can see it visually. So the graph of y equals x minus 2 in parentheses squared is right here. And so it says at what interval is the function increasing, on what interval is it decreasing. So we look from our x, from our farthest x, negative infinity, to our farthest y, positive infinity. And so we trace it. So we're going down, so we're decreasing until we get here. So that interval is from negative infinity, we're decreasing to until we get here to positive 2. So and then that's decreasing. So we're decreasing from parentheses, negative infinity to negative is a positive 2, and it's a brackets, okay? And then at 2, we are increasing to the right. And so we are continually increasing to the right, and that would be positive 2. Hello, Mr. Thomas.
Hello.
we are making a pre-calc video of a 12 basic functions. Okay, and so the interval is increasing from 2 to positive infinity, and it is decreasing from negative infinity to 2. And then B is the function odd or even or neither. And so we look at our end behavior. It ends the same direction. They're both ending up. And so this would be an even function. Does the function have any extrema? And so we look and see if we have any max or mins and see what that value is. And so it's a parabola, and our minimum vertex is right there at 2, 0. And so that is our minimum at 2, 0. How does the graph relate to the graph of the basic function? And so that's where we have that previous slide over your basic, your OGs. We have y equals x squared is through the origin, and it looks like this. So how does it compare? It shifts to the left or right 2 units, okay? And so right 2 units. And the reason why is because this -2 that's in the parentheses. And then let's talk about domain and range. And so domain are all the possible x values, and your range are the possible y values. Okay, so x values is left and right, x-axis is left and right. So with the black graph that we have, we're looking from possible left to possible right. Well, these arrows means it goes forever left, it goes forever right. There's all possible x values. So our domain here is from negative infinity to positive infinity. Okay. And now let's talk about range. Range is the y values. So now we're looking from bottom to top. What's the lowest value to the highest value? And if you see here, it doesn't go forever to the bottom. Okay. It stops right here at 0. And so all of our y values are going to be greater than or equal to 0. Okay, so our solution set here would be from 0, which is included, all the way up to a positive infinity because it goes up. Okay, and so those, you're going to have to be able to answer all of those questions based off your graph and use Desmos to graph it and then answer these questions. Okay, so let's see what else we got. And now we have, at what interval is this increasing? So we have an absolute value graph. It is moved up from our parent function, and so we're talking about interval is increasing and where is it decreasing. So looking from left to right, we have negative infinity over this way, we have positive infinity this way. And so our graph, it starts by decreasing to here, and then it's increasing there. Okay, so what interval is a function increasing? It starts increasing from 0 to the right towards positive infinity. And so I'm just going to put right here, 0 is included, so it's a bracket, to positive infinity. And then at what interval is the function decreasing? That is from the negatives to 0. So negative infinity to 0 would be at what interval it is decreasing. And then 0. Okay, so now let's talk about determining a function for piecewise. Piecewise function it's going to be 2 graphs into 1. Okay, and so you're given parameters on each specific graph. I don't know. Oh, I don't know why that's over there. Okay, so we have these f of x. We have so x squared if x is less than or equal to 0, and then we have another, the square root of x, if x is greater than 0. So we're going to look at each piece and piece them together, and it says the function is continuous. So from left to right, we don't pick up our pencil. And so for looking at x squared, if x is less than or equal to 0, that would be the negative x values for our graph. And so if x squared is a parabola like this, okay, if we have the negative x values, that would be this left side of the graph. And so we are going to graph that part, okay? Now the second half of that is the square root of x if x is greater than 0, okay? So if x is greater than 0, we know that the square root, well, always our x's are positive, so it's gonna look like that anyway. And so we're gonna take that part and we're gonna put it here. And it's those two graphs graphed together. And it's continuous, so there we go. There's a graph. I mean, pretty close to what I drew. And that's you go. There's your piecewise function, okay? And that is it for 1.3. So you have 10 questions in Math XL. Let me know if you have any questions. Bye.